Welcome to the Explainer. Today, we're tearing open the black box of AI. We are diving into the cinematic, sometimes slightly mysterious world of AI explainability to uncover the actual truth behind the machine's choices. We're going to see exactly how we can peer inside the algorithms that are making massive decisions every single day. Picture this. You're sitting in a review meeting, and your highly optimized XGBoost model is screaming that there's an 81% churn risk for customer 342. Your business manager points at the screen, looks right at you, and demands to know exactly why this is happening. The AI knows, but can it explain itself?
Section 1. The black box problem.
See, this is the classic interrogation room scenario of modern data science. Most AI models, they're fantastic at predicting the future, but they are notoriously terrible at explaining how they got there. Without the right tools, your only defense is literally, well, the model says so. But with SHAP, you unlock the exact reasons and the precise feature breakdowns driving that risk. You go from guessing to knowing.
Section 2. What actually are SHAP values?
Okay, so what is this tool that turns a silent black box into a star witness? SHAP, which stands for Shapley Additive Explanations, actually originates from game theory. It mathematically measures the precise force every single variable exerts on a final outcome. Think of it like 5 friends pitching in to buy a pizza. If one guy eats 3 extra slices, he should probably pay a bit more of the bill, right? Well, SHAP does exactly this for your data. It calculates precisely how much each feature contributed to moving a specific prediction away from the baseline average.
Section 3. The global view.
Now, to really understand how the AI thinks on a macro scale, we've got to look at the global view. And the Beeswarm plot is beautiful for this. It's not just some boring list of important features. It's this elegant, multidimensional map. It visualizes feature importance, the direction of the impact, and the distribution, all simultaneously across your entire dataset. It reveals not just what features matter globally, but exactly how they sway the model's overall logic.
Here's how you read it. Red dots represent high values of a feature, and blue dots represent low values. By watching those high values in red or low values in blue shift left, meaning a lower prediction risk, or shift right, meaning a higher prediction risk, you instantly see whether a trait is a danger or a protective factor. It is a massive upgrade from standard feature importance charts.
Section 4. Explaining Customer 342.
All right, let's zoom back in from that global view and apply this precise mathematical logic to interrogate the exact case of customer 342. We're going to use a force plot visualization, and we just follow 4 clear steps. Step 1, we start at a baseline prediction, basically the dataset's average risk. Step 2, we add the specific risk factors pushing the needle up for this individual. Step 3, we subtract the protective factors pulling it down. And step 4, we arrive at our final prediction. Let's look at the actual numbers. So for customer 342, the model found they had been inactive for 142 days. That single feature was a massive red flag. It violently pushed their churn risk up by 34 percentage points, all on its out. Then, an RFM score of 18 compounded the danger, jacking the risk up by another 21 points. You can literally see the algorithms stacking the evidence against them. But wait, the risk isn't entirely one-sided here. Their historical high spend of 12,000 rupees acted as a really strong protective factor. It actively grabbed that risk and pulled it back down by 12 points. So when you add all these contributing forces together, the baseline average plus the inactivity penalty plus the RFM penalty minus that high spend protection, the math perfectly aligns to that terrifying 81% final churn prediction. Boom. The black box is officially open. You can look your manager in the eye and tell them exactly what happened.
Section 5. Common SHAP mistakes.
As powerful as SHAP is, mishandling this evidence can lead your business totally astray. A huge mistake I see all the time, running SHAP on your entire data set. You've got to always run it on your test set only, because running it on the training data gives you these artificially optimistic explanations. Also, just relying on standard model feature importances instead of a SHAP summary plot, really dangerous. Standard importance is purely global, and it can be highly misleading when you're trying to explain individual behavior. You also really have to remember that SHAP shows correlation, not causation. Sure, days inactive is mathematically linked to churn, but SHAP doesn't inherently prove it causes it. Furthermore, ignoring negative SHAP values is a huge missed opportunity. Just like we saw with customer 342, Negative SHAP values are actually crucial protective factors. They provide massive actionable insights you definitely shouldn't ignore. Section 6. Driving real business impact. Ultimately, interpreting this evidence correctly fundamentally changes how a business operates. You are no longer selling a CSV of churn probabilities. You're selling a ranked action list backed by real explanations. Whether you're interviewing for a top role or freelancing for a client, providing this context transforms your work from a generic data dump into a premium consultative deliverable. You aren't just giving them the what, you're giving them the why. Instead of just dropping an 87% risk score on someone's desk, SHAP lets you declare the primary driver, like, say, 122 days inactive, and directly pair it with a recommended action, like launching a re-engagement campaign. Because of this, retention teams aren't guessing anymore. They know exactly who to call, exactly why they are at risk, and the precise action needed to save them.
Which brings us to the ultimate question. In a world increasingly run by complex algorithms, from approving loans to diagnosing patients, if your AI can't explain itself, can you really trust it? Explainability isn't some nice-to-have luxury anymore. It is the absolute foundation of trust in production systems. Before we wrap up this explainer, I've got a challenge for you. Imagine your SHAP Beeswarm plot shows a high RFM score and high total spend, pushing the prediction to the left, indicating a lower churn risk. How would you explain this specific pattern to a non-technical business stakeholder in just 2 sentences? Drop your best 2-sentence explanation in the comments below, and let's see who has truly mastered the art of humanizing AI. Thanks so much for exploring this with me today. Keep learning, and I'll catch you on the next one.